Welcome back again. We will continue the previous session. In previous session, we have seen the ultimate analysis of the coal. In ultimate analysis of the coal, we have already studied the first method, that is percentage of the carbon and percentage of the hydrogen. Now in today's session, we will see the percentage of hydrogen, determination of percentage of hydrogen from the coal sample by using Zeldal's method, their principle, experimental procedure, reaction, calculation part, as well as determine the percentage of the sulfur, as well as determine the percentage of oxygen, percentage of ash content from the coal sample, and the significance of the ultimate analysis of the coal sample. So let's begin with our topic, that is determination of percentage of nitrogen from the coal sample using Geldal's method. Now we will see the PowerPoint presentation, the determination for nitrogen. Percentage of nitrogen, it can be determined by using the Geldal's method. What is the principle of this method? Nitrogen in coal gets converted into ammonium sulfate, right? Suppose this is the nitrogen, it is present in the coal sample, it is converted into what? Ammonium sulfate. By action of hot concentrated sulfuric acid and then treatment with alkali solution, equivalent amount of ammonia is liberated, right? So this is the experimental setup of the Geldal's method, right? The number one is what your this is called as your Geldal's flask. In this Geldal's flask, coal sample plus concentrated sulfuric acid plus potassium sulfate crystal is taken, right? Then in this second experimental setup, here is what a standard acid solution, mostly sulfuric acid we can take, and here is the solution, this Geldal's plus solution we can pass into this beaker. Now we will see the procedure. A known weight of coal powder is heated with concentrated sulfuric acid. In this Geldal's flask, take the known quantity of the coal sample, right? And this coal powder is heated in presence of concentrated sulfuric acid by using potassium sulfate and copper sulfate as an catalyst. So coal powder plus sulfuric acid using potassium sulfate and copper sulfate catalyst, it converted into what? It gives ammonium sulfate, right? Then concentrated NaOH solution is added to above solution, means this solution we have to again pass into this beaker, right? And here is concentrated NaOH solution can be add, right? So it can liberate what? Ammonia gas. So here is what, this is the ammonium sulfate solution, then we are going to add the NaOH solution, it liberate what? Ammonia gas, right? Then the liberated this liberated ammonia gas, right, is passed into known volume of standard sulfuric acid solution. In this beaker we have to take the standard sulfuric acid solution, right? Here neutralize some quantity of acid and some quantity of acid remain unreacted, right? The quantity of unreacted sulfuric acid is determined by titration with standard NaOH solution using phenolphthalein indicator, right? And from the above titration reading, volume of acid neutralized by ammonia is calculated, right? And this is the reaction part. See, the calculation is very simple. Percentage of nitrogen, right? Percentage of nitrogen which is equal to volume of acid consumed. This volume of acid consumed is nothing but what? Your blank titration reading minus back titration reading into normality into 1.4 divided by weight of coal taken, right? So in short, this formula becomes what? V2 minus V1 into normality into 1.4 divided by weight of coal sample, and by using this formula we can determine the percentage of nitrogen present in the coal sample, right? So this 1.4 is the factor, atomic weight of nitrogen is the 14, right? So 14 into 100 divided by 1000, that is what, 1.4 factor, right? So based on this, numerical will be asked to determine the percentage of nitrogen present in the coal sample. Okay, I think you understood this. This is the nitrogen content. We will see the second is determination of the sulfur in ultimate analysis. When the sulfur containing coal is heated in bomb calorimeter containing small amount of water, right, it gives sulfate ion. Then a solution of barium chloride is added to get barium sulfate. So the reaction part is very simple. Sulfur plus oxygen gives sulfur dioxide. Sulfur dioxide plus oxygen gives sulfur trioxide. In presence of water, converted into sulfuric acid. In presence of barium chloride, it forms barium sulfate precipitate. Then the barium sulfate precipitate is filter, wash it, dry it, right, and take the weight of barium sulfate precipitate. So the percentage of sulfur, which is equal to weight of barium sulfate precipitate divided by weight of coal into 32 divided by 233 into 100. 32 is the atomic weight of sulfur. 233 is the atomic weight of what? Barium sulfate. Why? Because sulfur is converted into what? Barium sulfate. That's why 32 sulfur atomic weight, 233 barium sulfate atomic weight. In this way, percentage of sulfur can be calculated from the coal sample. The next one is determination of percentage of the ash. So same procedure, ash is determined in the same way as carried out in what? Proximate analysis of coal. That is, a known quantity of coal sample is heated in oven at 110 degrees Celsius for the period of what? 1 hour. Then loss in weight divided by weight of coal into 100. And last one is percentage of oxygen. It is obtained by subtracting, right? So it is obtained by subtracting the sum of percentage of carbon, hydrogen, sulfur, nitrogen, ash from 100. By using this, we can determine percentage of oxygen. Now, what is the significance of the ultimate analysis? The significance of the ultimate analysis is it should have high carbon content. Why high carbon content is required? Because percentage of carbon increases, calorific values goes on increasing. That's why it should have high carbon content. Second one is it should have smaller percentage of hydrogen content. Third is it should have small quantity of nitrogen. Then a good quality of coal, it should also contain low amount of the sulfur. Very low amount of sulfur is required. Then fifth one is a good quality of coal, it should contain low percentage of oxygen and it should have less percentage of the ash, because due to presence of the ash is the non-combustible inorganic matter, it can reduce the calorific value of the coal, right? So I think we will stop here. So I hope that you understood the determination method of the nitrogen by Geldahl's method, determination method of the sulfur in coal sample, determination of the oxygen, determination of the ash, and the significance of the ultimate analysis. I hope that you understood this, right? Thank you very much. We will conclude here. Thank you.